Okay, welcome back to the latest and greatest webinar on CIS-211 here at GMC. I am Professor Lusby, and this is your Week 6 webinar video. And I want to go over what it is exactly that we do for Week 6, basically the same format that you've seen in previous webinars. So with that said, I'm going to go ahead and dive right in here. Obviously, everyone should be comfortable with the classroom by now. The most important link being this virtual desktop that has everything installed that you need, including NetBeans 8 and the proper Java JDK. All right, so with that said, let's take a look at Week 6. Week 6 is all about Chapter 14 in your book. And Chapter 14, this is where we start to get into the fun stuff. Okay, so we've learned about all these primitive data types like strings and ints and floats, and that's all great to store, let's say, a single piece of information, or using an array we can kind of chain together a bunch of similar data types and store multiple pieces of information that way. But they're very rigid, and for instance, if you need to do, let's say, a search or a sort, or let's say an insert or a delete, that's where these primitive data structures kind of fall short. All right, and so they want to introduce you here in Chapter 14 to some more advanced data structures that have good CRUD operations, right? Create, read, update, and delete. And these are data structures like linked lists, stacks, queues, okay, doubly linked lists, okay, and these are kind of the basic advanced data structures. There's a whole host of others, but I think this is not a data structures and algorithms course, so or textbook. They just kind of want to dip your toe in the water here, and that's what Unit 14 is all about. So for sure, make sure you dive right in. It is a lengthy chapter, but you do have, if we look at Unit Week 6, a quiz, right? Just like we do each week, and this particular quiz is going to quiz you over Chapter 10. Well, that's definitely not right. It should quiz you over Chapter 14. I'm going to look into that. And you basically have 10, right? 10 questions, 2 are open response, 25 minutes, and you only have 1 attempt at that quiz. Okay. Right. So definitely read Chapter 14 and get to know it well before taking the quiz. All right, what else do we need to do? As always, a discussion forum and a programming assignment. Let's take a look at the discussion that we want to do this week, and we're going to see that unlike other weeks, instead of trying to come up with a solution, they really want us to just focus in on reading code, right? Because reading code is just as important as writing code, especially in industry, because when you go to start to work for a company, 9 times out of 10 they already have a code base that they want you to work on, right? And you're not going to be creating this stuff from scratch. And so yeah, it is advantageous to be able to look at code and understand what is going on, because more than likely they're going to be using some sort of advanced data structures when they're storing their data. So it looks like there's 1, 2, 3, 4, 5 classes that they want you to take a look at, and that's what I want to do with you right now, is just because I know some of you are fairly new to this. And so let's take a look at each one of these, and these are examples in Chapter 14. Let's take a look at this first one, this class called player. It's an example 14.4, but 14.4 is kind of weird the way they do this, is inside of 14.2. Right? I'm not sure why they should have, note to publisher, line up your example numbers with the actual unit numbers in the chapter. That would be great. All right. All right, so here is the first example they want us to take a look at inside of chapter 14 called the player class. And here we're going to see that this is basically just a container class, what's called a container class, where obviously the name of the class is player, and it's storing these three pieces of information, right? An integer called ID, a string called name, and another string called game. All right. Notice they're all private, and that is intentional, right? We per the encapsulation, right? In order to adhere to encapsulation, we do not want to expose the variables. We want to make them private. Well, then the question is, well, how do you access these variables? Well, we got a bunch of getters for each one of these member variables. We have a bunch of setters for each one of these member variables, as well as an equals, which can test to see if either one of these player objects is equal to each other, right? The ID and the name is equal, as well as a toString method. If we go to print out this player object, it'll print out all three important pieces of information about it. Okay, so this is just a container class, and this will come in handy for your assignment later on. Now, the other class I believe that they want us to look at is the player node. And if we look at the player node, we're going to see that this class called player node uses, right, that container class up above called player, and so it's going to store inside of it a pointer to this player object, a single player object, as well as a next pointer that lets you know, well, where's the next player node after this one. All right, so very similar to a linked list construct, right, where every node has a pointer to the next one. And some of these linked list structures actually have a previous pointer as well, but in this particular case, this is what's called a singly linked list. It only has next, it does not have previous. If it were to have previous, well, now we have a doubly linked list structure. And so that's kind of the story behind this particular class, is that, yeah, it stores the player container, player data information in this variable called player, and it also points to the next one, the next player node in the list. All right, so the whole point of this particular class here is to link together all these player objects. All right, and we'll see that there's a couple different constructors, right? This is the default one, this is the overloaded one, just in case you do have a player object that you want this list to remember. We can use this overloaded one. And then we have accessors and mutators, or getters and setters, for each of these two variables. Okay, so to high level the player node gives us a way to chain together a bunch of these player objects. Okay, I believe the other, shell linked list. So then if we scroll down a little bit more, here in example 14.6, right below that, we were talking about this player node class and a linked list. Well, the other thing that a linked list needs to have is what's called a head node. All right, so they came up with this class here called shell linked list that remembers, well, which of those nodes are at the head of the list. And that's important, right? Because we have a bunch of next pointers, right? We've got a bunch of next pointers. And so if you don't know which one's the head, let's say that you grab the player node at the very end of the list, well, there's no way to get to the other player nodes that are before it. So for sure, we need to remember the head node so that we can cycle through that list of player nodes. All right, and that's what this, it is an abstract class. We'll talk about that in a second, but that's kind of the whole purpose of this shell link list is, number one, which one of these is the head so that we can traverse through them all. And number two, well, how many items, how many nodes are inside of this linked list. And honestly, this is optional. It does come in handy, but as long as you have the head, you can always start at the head and work your way all the way to the end of the list. Number of items is more for informational purposes. Well, how many nodes are contained inside of this shell link list? All right, and so we'll see here, yeah, we have the constructor that initializes those two variables. Yeah, we have an accessor method for the number of, or a getter for the number of items inside of it. So the number of items, why it's useful is we have this method here called isEmpty, and we can just check, well, is number of items 0? If the answer is yes, well, then it's empty. If the answer is no, well, then it's not empty. So that helps there, as well as a toString method, right? If we print out this linked list, it's able to go to the head node of this linked list and then basically scroll through all those nodes using the get next pointer, the next pointer, and say, okay, well, give me the next one, give me the next one. And every time you get a node out of that linked list, we'll call the toString method on each one of those player nodes, and we can get a nice list of everything that is inside of the shell linked list class. Okay, so you can see how each class is building upon the previous one in order to store this data in a nice organized way. Okay, all right, so that's the shell linked list. Then the discussion wants us to look at the player linked list. All right, well, if we look at the player linked list, I believe that is right underneath of here. Yep. And notice that the shell linked list is an abstract class. All right. Why is it an abstract class? Because you're not supposed to use it directly. You're only supposed to build on top of it. All right. And so if we come down here to the player linked list, we're going to see that it extends the shell linked list class. And the reason being that it adds some new methods that are going to come in really handy. Remember, like I was talking about earlier, the CRUD operations, create, read, update, delete. Well, this is the create or the insert method that is able to take a new player, create a node out of it, and then basically stick it into the shell linked list data structure. Okay, and also increment the number of items and update the head node. So, you know, these, when we are inserting into a linked list, these are the 4 steps that are necessary. And the cool part is we wrapped all 4 of these steps up into a nice little insert method that anybody can use. They don't even need to know how this is working right under the hood. It just works. It knows how to create the node. It knows how to set the head pointer. It knows how to set the previous head's next pointer. It knows how to increase the number of items. All right, so there's insert. Here's delete. Well, what if we want to delete a particular player out of that linked list? Well, that's what this does. It has a while loop that looks at all the players' IDs. Once it matches, right, an ID with a particular search ID, well, then it basically drops out of this loop, and if the current pointer is equal to null, well, then guess what? This while loop didn't find it. All right, so go ahead and throw an exception saying, hey, I can't find that node that you need me to find. Otherwise, if this is false, well, we did find it, and because we found it, we need to do some pointer manipulation. We need to delete the head. We need to move the next pointer just in case it is at the head of the list. We have to reduce the number of items by 1. right? And then return the player node. So notice delete is pretty darn complex, right? You have to go through all those linked list items that are connected and look for it. And then once you find it, make sure you update those next pointers appropriately for the items before and after it. All right. A peek basically means that you want to find a node in the list, but you don't want to remove it. Okay, delete removes it. Peek just says, go find it and return it to me, but don't actually remove it. Okay, which is why you don't see number of items being updated here, because we're not removing it. In fact, some people call this search instead of peek. Okay, peek is an old school term for search. There also used to be a term called poke back in the day. There was peeking and there was poking, which is basically an insert. All right, enough about that. So that is the which method class? Player linked list. And player linked list just builds on shell linked list. Well, then what else? Let's build on player linked list, and let's talk about player queue linked list. Okay, we're going way down the rabbit hole here, and we're going to build on top of this class and say, you know what? Well, this is the test. Let me see if I can find the queue linked list. I assume it's in 14.3. Player stack linked list. No. They want us to look at, here it is. Player queue linked list. Now, what in the heck is the difference between a player linked list and a player queue linked list? So, again, once you take a data structures and algorithms course, you're going to see that there's a few different advanced data structures, but some of the more common ones are called queues and stacks. And a queue is basically a way of loading data into a linked list, but it has a behavior. And the behavior of a queue it's called FIFO, first in, first out. It's basically like at the grocery store. When you go to the grocery store and you're ready to check out, well, you get in line. And whoever is at the front of the line gets service next. Whoever is at the back of the line has to wait until they get to the front of the line. So what they did here was they gave us a new class called player queue linked list that builds, right, on the shell linked list, just like the player linked list did. But when we have a queue, it's not called insert. It's called onQueue. And the onQueue basically takes that player node, right? Because the old insert operation, we could insert that that player node anywhere we want inside of that linked list. However, since this is a queue, we have to behave like we're a queue. And when we go to insert a player object into a queue or enqueue it, I don't know if it's onQueue or enqueue. I think it's enqueue it. All right. It has to go at the back of the line. All right. As the tail, back of the line. And so that's the purpose of this queue linked list, is to make sure that if you insert inside of this queue linked list, yeah, you go to the back of the line. And we update our next pointers appropriately when that player node is inserted into a queue. All right. So enqueue is nothing more than an insert method for a queue. Then we see dequeue, and that is the delete method of a queue. But when we dequeue from the front of the line, right? Who's the next person in line that needs serviced, or who's the next player in the linked list that needs serviced, and we grab the node that is at the front of the queue or the linked list. All right, so notice that that is what this does here, is that, well, if it's empty, obviously we can't remove anything, but if it's not empty, if that linked list is not empty, well then grab the one at the head, the node at the head, and return that player node. That's a DQ, right? Return the node at the front of the linked list. And then peek is, well, I want you to return me the player node information that is at the front of the line. Notice peek only looks at the head, right? If we have a queue, you can only remove or look at whoever's at the front of the line. You can't look at or service anybody behind that person in the front, or the player node in the front. Okay, so notice how each of these classes builds right on the previous one, and in theory we can just create a player queue linked list class now, and enqueue and dequeue players, and we don't have to know about all of these head pointers and what was the other, number of items being incremented and decremented. That's the beauty of object-oriented programming, is that you can keep building on a previous class. You can keep extending it. Okay. So I think that, in a nutshell, basically answers these questions here, and see if you can, you know, describe kind of what I talked about there with these questions. All right, because yeah, in industry you do need to be able to look at this code and read and interpret its behavior. And when you're new to this, yeah, it might take some time to really read this. But my thing is, you have to know how to read before you can write. Okay, just like in elementary school, right? They didn't ask us to sit down and write a book, right? They taught us how to read each letter, and then they taught us how to start putting them together and sounding them out. That's exactly what you do in code as well. Find a bunch of good examples, learn how to read those examples before you dive in and start trying to create your own linked list. Probably not the best idea. All right. What else? So that is, the discussion. So we talked about the quiz, we talked about the discussion, we talked about chapter 14. What about the programming assignment? All right, the programming assignment asks us to do the following. Create a restaurant application that is going to allow the waiter or the employee to enter the customer's name and what they would like to enter or order on the restaurant menu. Looks like the application should have an option for the kitchen that's going to pull the next order on a first come, first served basis. So as soon as you read that, oh, that's a queue. I need to put the orders into a queue. FIFO, first come, first served. If it was a stack, it would be a last in, first out, or a LIFO. But this is a first in, first out, so we know that we need to implement some sort of queue behavior. Ensure that you utilize, here it is, queue data structure to store the orders for the application. The output should look like the following. So basically it presents us with a menu. This is a command line interface type of application. It says, well, what do you want to do? Do you want to place an order? Do you want, do you want the waiter to place an order, or do you want the kitchen to grab the next order? And what this means is, well, if you place an order, then you in queue or on queue, however you want to say it. You put that order into the queue. If you're the kitchen and you get the next order, you're dequeuing. You are removing the order from the queue in FIFO order, first in, first out. All right, and so yeah, this is the program saying, which one of these would you like to do? It looks like this is the waiter. They select number 1 and they go, okay, well, Jack wants an apple pie. And then the program should tell us that, well, yeah, I placed the order in the queue, behind the scenes in a queue. Then we see the menu again because they didn't select option 3, right? See the menu again, and we got another customer. So the waiter types 1, well, Bob wants steak and fries, and so it says order placed. We present the menu again, right? Because they haven't selected 3. Then we got Lisa. The waiter types in number 1. Lisa wants sushi. That places that order into the queue, and we present the menu again, or the program presents the menu again. This time it's the kitchen though, right? Kitchen selects number 2, which says, well, let's get the next order to service. Notice it's Jack with the apple pie. Why? Because he was the first one in line. He was the first one that ordered. Okay, so this queue, when we dequeue, should automatically return back that first order, which is Jack and apple pie. If we select number 2 again, which is, well, I'm the kitchen, I'm trying to get the next order after that, well, that's Bob with the steak and the fries. Why Bob? Because that was the second order entered into the system, right? So notice that Lisa is nowhere on the radar yet because she was 3rd in line. All right, and at this point, I don't know, the restaurant shuts down. I don't know, they don't have time for Lisa's order. They select number 3, and it basically says, okay, quit selected, application is shutting down. All right, now here it does say that you can use code from chapter 14, in particular this player queue linked list, but notice that you would have to use the other 3 classes that this builds on. That is definitely one option, but I'm going to show you another way that I believe is a little bit easier. Okay, right. So how do we go about completing this particular assignment? Well, we need to launch our handy dandy remote desktop, right? So go to the top of the classroom, click on remote desktop, enter in your GMC username and password credentials. Let's go ahead and launch NetBeans, and let's create a new project. All right, Java application, nice descriptive name. I believe this is CIS-211 week 6 programming activity. Because I already have one, I'm going to put V2. Yes, we do need to create code. Okay, this is a programming activity that does not that we're supposed to write from scratch. All right, so there's no, I mean, there is code in the textbook that you can use. I suppose you could try to find it in the textbook activity frameworks folder, but I'm going to show you another way that I think is a little bit easier as a reward for those of you who are actually watching this entire video. Okay, go ahead and click on finish. Make sure that this is left as the default. Do not check this. Make sure this one is checked, and we should have a nice empty we have a class defined here, right, that has our main method in it, and we are ready to start cranking out our code. All right. So what's the next step here? Well, so I took some time before this webinar, and I wanted to give you a little bit of guidance here. For sure, let me go ahead and save this. For sure, we have this Java file that contains our main method. All right. We also want to create a class, a container class that's going to hold our order. So for sure, come in here, right click on default package, say new Java class, and let's create a new class, I don't know, called order. Call me crazy, because that's what we are, that's what we need to store the customer's data, right? The name and what it is that they are ordering. And so just change class name to order or something descriptive like that, and click on finish. All right, and we should see that our project now contains these two classes. Notice they are both in their own Java file. All right, well, what in the heck do we put inside of these classes, right? So that is where I worked on this a little bit beforehand. And for your, I'll even help you out with the container class. All right, you basically need a name and a description, right? Who is this order for, and what is it that they're ordering, their description. Notice I made them both private because that's what good object-oriented principles state. Encapsulation, do not expose the data that is underneath of the class. And we need, well, we don't need it. It's advantageous to create an overloaded constructor that will take the name and the description and go ahead and initialize the name and the description for us inside of this order object. We could do a default constructor, but that's not going to initialize the name and what the customer is ordering. So overloaded constructor, something like this, and then yeah, let's create an accessor method or a get method that will at least at a minimum return the name. But yeah, there is a little bit of homework here, right? You also need to create the get description method here, right? So that, well, this returns the name. Well, what about the actual description itself? Okay, and maybe even the set name, I guess if the customer ever changes their name, it's good practice to create getters and setters for all member variables. And maybe even the what is it? Set description, in case the customer changes their mind. They never do that, right? And I used to work in a kitchen, so I can relate. All right, get description, set name. So we have getters and setters. Yeah, get. Oh, I meant set description, not get. Sorry. We have getters and setters for each one of our member variables. All right, so this will give us our container class. Now, how do we use this container class? Well, if we go back to that class where our main method is defined, here's what I'm going to suggest. Instead of using in the book all, those 3 or 4 classes, you could type in, create 4 Java files with the definitions of the player, well, I would call it order queue linked list class, right? And you could create all the classes necessary in order to get to here, or use the linked list queue class that's already built into Java. All right, so make sure that you import those libraries. And the cool thing is that it's built on something called a template, to where you can declare the queue and you can give it your own custom container object. So notice we created this order class. Well, we can say, hey, create a queue that can store these order objects and call it order queue. So when we declare a template object, there's 3 pieces needed. It's not just like int. It's not like an int or a string where you just give it data type and name. Here it's the template class, the what it's going to be holding, and the name. So there's 3 parts to this when we're using templates. And then we say new linked list, just like we would for a normal class. But notice that, yeah, we need to specify that we're using a template here. And we just call the default constructor. All right, so you can create your own container class, put it here, call it whatever you want, and here's the cool part. This queue already has functionality in it, so we can just call add. So apparently they didn't follow the rules of using enqueue and dequeue. This particular queue class, and you can look it up online, look up this library, and you'll see all the different methods available. Or, in fact, you can even click on dot and see all the methods here if you're using NetBeans. Another reason to use a real IDE is that it'll kind of show you what's available. But for this particular assignment, you really only need add, which is adding to the queue, and remove, which is removing from the queue or dequeuing when you want an order. And this is all just kind of a demo. I wanted to be very clear how this queue class works. All right, so I put in kind of this demo code here. This is not what I'm looking for on the assignment. What I'm looking for on the assignment is this. All right, let's talk about this pseudocode. All right, this is just kind of to get your feet wet with how this queue works, how you add and remove items from the queue. All right, so this right here is just a demo. All right, so for the assignment, this is kind of what I came up with pseudocode. Is, well, yeah, we need to display the menu to the user, right? If we look at the assignment here, we keep seeing this menu, so for sure we want to display, and don't get creative here. We want to make sure that you meet the requirements specified. All right, so I should see a menu that looks exactly like what's in your assignment description, and then ask the user, right? Well, what menu selection would you like here? And once the user types it in, store it in a variable called menu select, or I guess you can pick whatever name you want, but I wanted to be specific so that when you see menu select down here in the pseudocode, you know this is where it's coming from. All right, it's from the user. They enter in what it is they want to do, and at that point we want to create a loop, an event-driven loop, a while loop that is going to basically it's going to keep looping until menu select is equal to 3. Well, why are we going to stop looping if menu select is equal to 3? Well, because that's the quit option. All right, so we want to create an outer loop, a while loop here that's basically going to say, okay, as long as menu select is not 3, then I'm going to do this stuff here, the loop body. And inside of the loop body, it's going to check and see, well, if menu select is equal to 1, is menu select equal to 1? Equal to 1 is true, I guess we should say. All right, okay, if that is true, then we're going to prompt the user for the customer name, right? We're going to input the customer name. We're going to prompt the user for the customer order. We're going to input the customer order, right? And then once we have the name and the order, and why are we doing this? Well, menu selection number 1 is customer place order. So that's why we're grabbing the name, we're grabbing the order, and then we create an order object, right? Remember that container class, this guy here, and we should create an order object that has that name and description inside of it, and call that order object, well, at least here, new order, and then let's add new order to the order queue, right? Remember, we created the order queue up here. Okay, so let's add that order to the order queue. So notice that if we use this order, right, this order queue, all we're doing is creating the data object and inserting or adding it to the queue. All right. If the user selects number 2 instead of number 1, right? If menu select is number 2 and not 1, well, in that case, that's the kitchen grabbing the next order. We want to retrieve the next order from the order queue using the, what is it called? the remove method. Okay, so the kitchen, when they say give me the next order, this is basically a call to the remove method that is going to grab the next order in line and remove it from the queue. And once you have it, well, in this case, we call it next order, and then we display that to the user, well, or to the kitchen, right? Well, this is what's contained inside of next order. And with that said, it might be really advantageous to add a toString method here. String method here, so that you can just say print order, print the order object, and it'll just print it out to the screen, and you don't have to add any more real logic here. You can just say print order object, print next order, and it'll call toString here and print out all the data. All right, so once we do that, right, we're inside the menu. The user selected either number 1 or 2. Obviously, the user's not done yet. They haven't selected menu option 3. Let's go ahead and display that menu to the user again, because we completed what it was that they wanted to do, either option number 1 or 2, and let's see if they want to either do number 1 or 2 again or quit. But notice that we have to display this menu in 2 different places. Once outside of the menu, outside of the loop, and once inside of the loop. All right, a lot of students get that mixed up and they don't realize. And if we had used a different loop, there is a do while loop and not a while loop. There is a do while loop where you could just display the menu once inside the loop and be fine. But I don't want to get into that right now. So make sure you display the menu again at the bottom of the event loop, the while loop, and make sure that you ask the user for the menu selection again. Right? Well, what is it? And store it in that same menu select variable so that when we come back to the top of the loop, which is what loops do, you're going to use that same condition and say, well, is menu select equal to 3? And if the answer is true, well, then we're going to jump out of this loop and we're, I guess we're supposed to print, what did it say? Print quit selected, application shutting down. Right, output quit selected, something like that. Because once you're outside the loop here, the user wants to quit the application. Okay, this should be. Is this the only way to do this? No. It is definitely one way that I believe is a fairly straightforward way. The only optimization I can see is maybe using a do while loop so that you don't have to display the menu twice here. But either way is fine. Okay, or come up with your own way and meet the requirements. All right, but I wanted to give you a little bit of guidance here. Okay. So that is your assignment. Obviously, once you're done, copy and paste the code into your results document, into your Word document, right? Literally say Control-A, Control-C, copy into your Word document, come in here in order, Control-A, Control-C, copy into your Word document, and then when you run it, right, I want to just do an entire screenshot. I can see your output down here. If you run this full test scenario that's outlined here, and maybe even you do some additional testing, which would be great. Notice it is going to run off the screen, right? This is a lot of output. So you may need to scroll to the top, take a screenshot with the timestamp at the bottom, scroll down a little bit, or scroll some more, take another screenshot. I do need to see the entire output. Okay, I do need to see how this program responds to each one of these menu items, right? And when the kitchen says, well, get the next order, well, I need to see all this stuff up here and verify that the kitchen is seeing the first order entered. All right, so definitely you're probably gonna need at least 2 screenshots, maybe more, of this output in your results document for full credit. All right. What else? Yeah, I guess that's about all I can think of. That is everything that needs to be done in week 6: discussion, program assignment, quiz. Please continue to provide me feedback on these webinars. Leave a comment, like it, whatever it is. Email me. That's definitely what keeps me going. And if you have if you need immediate assistance, please email me, and I'll see if I can provide guidance without providing a solution. Okay, so have a great rest of your week, and please let me know how I can help.